So in this discussion, we will be talking about immutable strings and is operator and double equal to and other some operators which are some peculiar to strings. Okay. So what I'll do, I'll just so when you say immutable strings in Python, strings cannot be changed. Okay, the content of a string cannot be changed. That's called immutable property. For example, at index position, given index position, I have a character, a word called welcome, and W is at position 0. Now I want to replace the W with some other character. Okay, for example, instead of W, I want to put S. Okay, that is not possible with string because string is immutable in Python. Okay, basically it's a value actually. A value is always a constant. Okay, so if at all you want to change the change the character at a given position, we need to create a new string with the new character at that specific position. So this will become entirely a new object. Okay, entirely new object. Okay, so I'll just demo it. I'll give a demo with this. I'll go to my Anaconda. So I can see here. Let me say name is equal to Raj. Okay. Now if I try to say name of 0, I try to assign some other. Instead of Raj, now I want to say Haj. Okay, H. I want to put name of 0 as H. If I control enter, okay, I should look at this. String object does not support item assignment. That means it is immutable. Okay. So now apart from this, now I can have something like this. I'll just say name, F name. Let me call F name, L name. F name is first name, L name is last name. So I'll call Raj, and I can have is operator. So I can say F name is L name. So F name and L name, see both refer to same object. So let us run it. True. So see, they refer to a single object, even though we assign differently to different variables, they refer to a single object. Okay, how can we cross check this? What I'll do, I'll just say id of print id of F name, comma id of L name. You can see now. Yeah, you can see here both contains value 0576, 0576. See, even though it's two different assignment, a single object is assigned to two variables. That is what is happening here. A single object is assigned to two variables. Okay, that means see the object is at the middle. Just assume that the object is at the middle. F name points from here, L name points from here. That's it. Okay, so that we have cross checked with the ID function also, identity function also. You can see here both F name and L name, they have same ID number. That means they refer to the same object. Okay. Suppose if I say instead of Raj, I get Raj 1. Now if I try to run it now, I'll get false. Of course, it's quite obvious. Now with Raj, you can see here, we'll get true because F name is L name, and I want to see F name double equal to L name. That means what? Both have the same content. See, when you say F name is L name, okay, we just check whether both variables refer to the same object. But when we say F name double equal to L name, we mean to say the contents are same. So it's quite obvious that when two variables refer to the same object, the contents of the two variables also must be same. Okay, must be same. So that is what this particular action brings into our notice. Now what I can do, I'll just put one exclamatory mark. Now you can just see the output. Okay, see, I'll just first let me comment it. See, it's false. Why? Even though I given Raj exclamation, see now Raj exclamation, it becomes a special character basically. Exclamation is special character. It's not a normal character, it's a special character. So when the special character is coming in, naturally what happens? A new object is created to which F name refers, and L name refers to a different object. So let us check the ID of these two. You can see here. See, even though they look same, suppose if you see, when you put F name is L name, we need to say whether F name and L name refer to the same objects. No, they don't refer to the same object. That has been proved at the bottom. Look at this. The IDs are different. Fname ID is 0368 and Lname ID is 3187, 3184. So definitely they are two different objects. Now, when I just comment it out and I want to check whether the contents are same. Look at this. Yeah, the contents are same. That means what? See, I have Raj exclamation here, Raj exclamation here. Now this is a different object, this is a different object. So their IDs are different. So F name refers to this, L name refers to this. So when you say F name is L name, you get false because their address is not same. Their identity is different. Okay, but if I say F name double equal to L name, the contents are same. The contents are same. This is also Raj exclamation. This is also Raj exclamation. So the contents are same. So that is how you have to understand this particular operator. Right? So these are some of the things we need to apply when we use strings. Right? Now if I go over here, apart from that we have something called operators. So when you say operators, I think these are the operators which we can discuss, because otherwise when you say multiplication, division, okay, they're all well known actually. Suppose division. When you say division means it's a real division, and I think we already discussed about it. Real division and floor division. But what is mod? Mod gives you the remainder. So let me say I have a cell here. Let me call num1 is equal to 100. Num2 is equal to 56. Just random numbers. So if I say num1, so let me put a small number. Let me take 6. So num1 mod num2. So output will be, so when you divide 10 by 6, we'll get a remainder of 4. So that's what you'll get. Okay. So to get the quotient, you have to go for double floor division. Look at this. 1. Quotient is 1. But when you put mod, you will get remainder. Okay, you will get remainder. Look at this. 4 is the remainder. Okay, so we can apply mod operator to check whether the number is divisible or not, or whether a number is odd or even. Suppose if I say, you can see here, I just comment it out. If num mod 2, look at this. If it is 0, then 10 is even number. Okay, suppose if it is odd, then 11 is odd number. 11 is odd number. Okay, so these are some of the things we need to know. And exponential is nothing but the power. Okay, when you say power operator. What is power operator? Look at this. Okay, so you see, I'll say A is equal to 10, B is equal to 3. Okay, so I can say A star B. So 10 power 3. So 10 into 10 into 10. So it will be 1000. So this is called power operator. Okay, fine. So when I say power operator, it always right to left actually. Because if I say C equal to 2, C is equal to 2, and if I say 2, so what should be the answer? So let me take it as 2, 3, and 4. So it will be 3 power 4. Okay, so suppose C. Let me see. So it should be 3 power 4. So 3 into 3, 3 is 9, 9 3 is 27, 27 into 3 is 81. So 81, 2 power 81. I think 2 big number. Yeah, such a big number. So let me put this way. 4, 3, 2. So it will be 3 square. So 3 square is 9, and 4 power 9. Okay, that means 4 into 4 into, I think 4 into 4, 16, 16, 64, 64 into 4 will be again a big number. So what I'll do, I just say 1, 2, 1, 2, 3. 1, 2, 3. Okay, so I think 2 power 3 is what? It should be 8. Okay, then 2 power 3 is 8. 1 power 8 is 8. So answer should be 8. Oh, 1. Oh, sorry. Okay, 1 power 8 is 1. Okay, so this is right. Okay, so you see, I put 3, 2, and 1. 3 to 1. So 2 power 1 is 2. Okay, 3 square will be 9. So answer should be 9. Correct. Okay, so this power operator is always right to left. Okay, the BODMAS rule, right to left. First, okay, when you have two power operators, first it is getting applied on the right side, then the result goes as power of the, okay, the remaining variable. For example, you see, P power C is calculated, you get a value, and that value becomes power of A. Okay, fine. So this is called, power operator. Then I can have, bitwise operators. When you say bitwise, no, normally a number, if you take a number, no, for example, I'll take x equal to 10, y is equal to 8. Suppose if I say print, okay, x bitwise and y. So in this case, what happens is you will get a binary of, so I'll just give a small demonstration. Look at this. Let me just write only the magnitude part. This is, okay, of course, this is 10, because see, 240, 241, 242, 243. So 243 means 8, plus 241 means 2. So you get 10 here. Then 8 I want. So 1, 0, 0, 0. So all, see, zeros. Then 1 into 2 power 3. So that will be 8. So when I multiply this, my answer should be 0 into 0, 0, 1 into 0, 0, 0 into 0, 0, 1 into 1 is 1. So answer should be 8. The answer is 8. This is called bitwise and. When you say bitwise or, single or, so answer will be 10. Okay, look at this. Because or means, 0, 0 means 0, 1, 0 means 1, 0, 0, 0, 1, 1 is also 1. So answer will be 10. Look at this, 10. So this is called bitwise or operator. Okay. Then of course, bitwise, XOR. So when you say XOR, no, see, wherever the bits are different, the output will be 1. So you see, so 0, 1, 0, 0. So answer should be 2. 2. Okay. So this XOR. Fine. So these are some of the operators which you can apply. And of course, the actual usage is, you can find whether a number is odd or even using bitwise operator. Okay. See, for example, you see, if I say, I comment it out, I just say x equal to 18. So 18, I want to check whether it is odd or even. So when you say 18, bitwise and 1. 1. Okay, so when you say 1 means, I'll just write it down. See, 18 will be 16, 0, 0, 1, 0. This will be 18. Okay, because you see 240, 241, 242, 243, 244. 244 is 16 plus 241 is 2. Now I want to check whether this is odd or even. So what it does is the bitwise and with 1. So when I say 1, this is what we do. Okay. Now you see bitwise and with 1. So 1, 0, 0, 1, 0, 0. So answer is 0. So if the answer is 0 means then the number is even. Look at it, it's even. 18 is even. Suppose if I take 19, then my bitwise and will be, look at this. This will be 19 because 16 plus 2 plus 1, 19. Now when I do bitwise and I'll get 1. Okay, I'll get 1. So look at this. 1. So if we get 1, then x is odd. X is odd. Okay. So these are the ways you apply bitwise operators. Bitwise operators. Okay, fine. So hope this was useful. Okay, we'll meet in the next discussion. Thank you.